Hello everyone, I hope you all are well. Welcome to our YouTube channel The Engineering Projects. Today, I am going to give you a detailed overview of Arduino Uno. We will first discuss the related theory, and later we'll simulate it in Proteus software. So, let's get started. I have divided this tutorial into 4 parts. In the first part, we will discuss the basic introduction of Arduino Uno, like what is Arduino Uno, why we need to use it, why is it so famous, etc. In the second part, we will discuss its hardware architecture, where we will have a look at its pinout, and the different functions associated with these pins like communication protocols, PWM, etc. In the third part, I will show you how to add its library to Proteus software for designing its simulation. And finally, in the last section, we will design a small simulation in Proteus software, in which we will interface LCD with Uno board, so that you guys could get an idea of how to practically work on this microcontroller board. I have also shared a complete tutorial on my blog and its link is given in the description of this YouTube video. Now let's have a look at what is Arduino Uno. If you have worked on any microcontroller before, like PIC or Atmel, then you must have the idea that a programming code is uploaded in the microcontroller. A developer writes the programming code in C or assembly language, and then compilers are used to compile those codes. These compilers simply create the hex file of the code, and this hex file is then uploaded in the microcontroller using a burner or programmer, as we use Picket3 for uploading code to PIC microcontroller. Moreover, in order to operate a microcontroller, we have to design its basic circuit first, where we use a crystal oscillator for frequency, and a master button for reset. Without a basic circuit, we can't operate a microcontroller. So, it's quite difficult to work on a standalone microcontroller. It involves circuit designing plus you have to purchase a programmer or burner in order to upload code. Arduino has solved both of these problems by creating these small plug-and-play boards. We don't need to design the basic circuit or to buy any external programmer. Instead, we just need to plug our board in the laptop, install its driver, and we are good to go. That's the reason Arduino boards have become so popular, as they are too easy to use. So, Arduino Uno is a small, flexible and user-friendly microcontroller board, developed by Arduino.cc. The microcontroller used in Arduino Uno is at Mega328. The basic circuit of this microcontroller is already designed on this board, as you can see here. We have this crystal oscillator. Arduino Uno comes with a crystal oscillator of 16 MHz. A driver called bootloader is pre-installed in the Uno board, which makes it compatible with Arduino IDE, and thus there's no need to use an external programmer for uploading code. It comes with an operating voltage of 5 volts, however, the input voltage may vary from 7 to 12 volts. Arduino Uno was initially designed for hobbyists and engineering students to learn embedded programming, but because of its easy-to-operate nature and extensive forum help, it got popular among embedded developers, and nowadays used in numerous industrial applications. Arduino Uno is used in embedded projects, mostly in automation, robotics and instrumentation. Now, let's have a look at its pinout. Arduino Uno contains 14 digital pins starting from D0 to D13, it has 8 analog pins starting from A0 to A7. Each of these digital and analog pins is assigned with multiple functions, but their main function is to be configured as either input or output. Let's understand it with an example. If you are interfacing any sensor, let's say temperature sensor with Arduino Uno, then in order to read the sensor's data, the Arduino pin should act as an input pin. But if you are interfacing any motor, the motor has no data to send. Instead, it's waiting for the instructions, and as we send commands from the microcontroller, it will start rotating either clockwise or anti-clockwise, depending on the instructions sent from these pins. So, in such cases, Arduino pins will act as output pins. We have to define in the programming whether we want to use them as input or output. As I mentioned earlier, other than acting as input or output, these pins are capable of performing several other functions. These functions are pin-specific. Let's discuss them in detail. Arduino Uno is capable of performing 3 types of communication protocols, named as Serial Protocol, SPI Protocol and I2C Protocol. Pin number 0 and 1, both are digital pins, but can also be used for serial communication, where pin number 0 is RX, used to receive serial data, while pin number 1 is TX, used to transmit serial data. We have to define it in the programming, whether we want to use these pins as input or output, or want to perform serial communication. As I said earlier, these functions are pin-specific, means if we want to interface any serial module with Uno, Then we have to connect it with pin 0 and 1, it won't work on any other pin. Although, we can create software serial on other pins, if we have to interface multiple serial modules with Arduino Uno. Check the software serial library for more details. Now let's have a look at SPI protocol. SPI protocol is carried out by 4 pins, which are pin number 10, 11, 12 and 13, where pin number 10 is SS short for slave select, pin number 11 is MOSI short for master out slave in. Pin number 12 is MISO, short for master and slave out, and pin number 13 is SCK, short for serial clock. So, using these 4 digital pins we can perform SPI protocol in Arduino Uno. The third protocol is I2C protocol. Pins used for I2C protocol are A4 and A5, these are analog pins. Here, A4 is SDA, short for data line, and A5 is SCL, short for clock line. Again, we have to define it in the programming, how we want to use these pins. Now let's have a look at few other functions these pins offer. Arduino Uno also has these 6 PWM pins, pin number 3, 5, 6, 9, 10 and 11. These pins are used in projects where you want to generate a modulated signal. For example, if you want to control the speed of a DC motor, you have to use any of these pins to generate the PWM signal. Pin number 2 and 3 are used for generating external interrupts, where pin number 2 is int0, short for interrupt 0, and pin number 3 is int1, short for interrupt 1. Check attach interrupt function for more details. It also has a built-in LED attached to pin number 13, which will turn on if you make this pin high and will turn off as the pin got low. It also has one reset pin, which is used for resetting the board programmatically. Making this pin low will reset the board. There's also a reset button present on the board. Arduino Uno has a DC power jack and a USB port. Both of these connectors are used for powering up Arduino Uno. Normally, a 12 volts adapter is used for powering up through this DC power jack. If you plug USB port only, it will also power up Arduino Uno, and this USB port is also used for interfacing Uno with the computer, to upload programming code. This USB port is internally connected with hardware serial pins 0 and 1. So, if you have connected any module with hardware serial pins, you won't be able to upload code. It also has 4 LEDs embedded on it. One is connected with pin number 13, second is power LED, it turns on if Arduino Uno is powered up. Third and fourth LEDs are connected to RX and TX respectively, and they will start blinking if there's any serial communication. Now, let's have a look at the built-in memories present in Arduino Uno. Arduino Uno comes with 3 types of built-in memories, named flash memory, also called ROM, SRAM memory, also called RAM, and EEPROM memory. Arduino Uno has a flash memory of 32 kilobytes. It's a non-volatile memory, meaning the data in ROM memory will remain intact, even if we remove the power supply of the Uno board. As it's a non-volatile memory, that's why it's used for storing the programming code or any permanent settings. Bootloader is a software code that is pre-installed in every Arduino board. It's installed in the flash memory of Arduino Uno and takes around 0.5 kilobytes space, so from 32 kilobytes flash memory, 0.5 kilobytes memory is already occupied by the bootloader. Second one is SRAM memory, it's short for static random access memory, and usually called RAM memory. Arduino Uno has a RAM memory of 2 kilobytes. It's a volatile memory, so if we reset or restart the Uno board, RAM memory will get erased. This memory is used to store temporary data like variables. Third type is EEPROM memory. Arduino Uno has an EEPROM memory of 1 kilobyte. It's a semi-volatile memory and thus can be erased by programming but remains intact if power is lost. So far, we have studied the theoretical knowledge about Arduino Uno. Now let's practically work on this powerful tiny board. I am not going to work on a real Arduino Uno board. Instead, I am going to design its simulation in Proteus software. If you want to learn the Arduino programming language, then I would recommend you to design simulations in Proteus. Working on real hardware is quite difficult, as you have to purchase the components and it also involves electronics. In Proteus simulation, you just have to design your circuit once, and then you can completely focus on your programming side. When I work on Arduino projects, I normally design my programming algorithms in Proteus, as testing with real hardware is too time-consuming. Proteus doesn't have Arduino boards in its components library, but we have designed its library, which you need to install in your Proteus software, and you will be able to simulate Arduino boards in it. We have designed 2 libraries of Proteus containing Arduino Uno board. I have given both of these links in the description of this YouTube video. This library is titled as Arduino Uno Library for Proteus version 2.0. If you install this library, it will only add Arduino Uno board in your Proteus software. In order to download it, click on this download button and it will open this download page, where we need to wait for 20 seconds. And here's the link generated. Let's click on this button to download zip file, and here we got our zip file for Arduino Uno Proteus library. I am going to click on cancel, as we will install this second library. This library is titled Arduino Library for Proteus version 2.0, and by installing this library you will get these 6 basic Arduino boards. So, let's install this second one, and again we need to click on the download